Kaitlyn and I am honored to have been awarded the LG Soderman Award for last term. Myself and my supervisor, Dr. Cedric Remy, are working on developing an energy-based method for determining the static liquefaction potential of soil. Liquefaction, while an old phenomenon, is a relatively new area of study. As such, it is still difficult to reliably determine if a particular soil may be susceptible to liquefaction. The most used methods are based on either a stress or a strain approach. They typically relate measurements from a test, such as a CPTU test, to a value that can be plotted on a chart that will say if the soil is liquefiable. This makes liquefaction assessments highly dependent on engineering judgment. An approach that combines both stress and strain values would take away a lot of the guesswork in today's liquefaction assessments. In 1995, a researcher named Dr. Liang established an energy-based method that can be used to predict cyclic liquefaction. Dr. Liang related the energy dissipated per unit volume in a soil to its liquefaction susceptibility. An energy-based method combines the stress and strain approaches, since both are used to calculate the energy in a soil. This method has been built on by other researchers to refine cyclic liquefaction assessments, but has not yet been applied to static liquefaction. Since cyclic liquefaction is often associated with earthquakes, it has been a lot easier to study than static liquefaction. It was not until recently, when static liquefaction caused multiple tailings dam failures, that it has been looked at the same as cyclic liquefaction. Our goal is to define an energy-based method for static liquefaction assessment. Currently, our objective is to run finite element analyses on soil slopes and determine the energy capacity from the model. We then want to correlate these energy values to those that we calculate from Traxel tests. From the preliminary analyses we have conducted, it does seem possible to apply Dr. Liang's method to static liquefaction. Additionally, we are calculating energy values from Traxel datasets that are in the literature. I am very excited to see where this research goes in the future. Thank you for listening to this short presentation.